Let's start with a review from yesterday about the periodic table. I want to look today at what we talked about yesterday as far as what we can find on the periodic table, and then talk about a few other bits of information that we can gain from looking at the periodic table as well. So first of all, as a bit of a review, we have the symbol in the box of the periodic table that basically represents the chemical that we're talking about. So if it's carbon, we use C for the symbol. There is a number at the top of the box in the periodic table. That number is the atomic number. And if you remember from yesterday, the atomic number tells us the number of protons. So the atomic number tells us the number of protons. Be a really good time to look at the atomic number and how it behaves as you go across the periodic table. Notice that you start with 1, you go to 2. When you go to the next row, you've got 3, 4, 5, 6, and so on. Come down to the next row, 11, 12, 13 through 18. So you can see that the numbers as you go across the periodic table just keep increasing by 1. So as you move across the elements, each one adds a proton. So the atomic number at the top of the box tells you the number of protons. We also know that the number of protons also equals the number of electrons. So the top number tells you the number of protons and likewise the number of electrons by default. At the bottom of the box, we have another number. This number represents the atomic mass number for the element. So in this case, the mass is 12.011. However, when we deal with the mass number, we are going to round to the nearest whole number. So the mass number for carbon would be 12. If we were looking at, say, aluminum, we would say that the mass number was 27 because we would take 26.98 and round up to 27. Chlorine would be 35. Argon would be 40. So we round to the nearest whole number for the mass number. The mass number is equal to the number of protons plus the number of neutrons. Protons and neutrons make up nearly all of the mass of the atom. So the mass number is a combination of the mass of the protons and the neutrons. So when you look at the box on a periodic table, the top number, the atomic number, tells you the number of protons, and that's equal to the number of electrons. The bottom number minus the top number will tell you the number of neutrons. Now, the way that the periodic table is laid out is in a series of rows and columns, and we have names for those. So, for example, here is a row on the periodic table. Here is a row on the periodic table. So there are 7 rows on the periodic table, and the rows are called periods, which is where the name periodic table comes from. There are also columns on the periodic table. So here's a column, here's a column, and here's a column. Those columns on the periodic table are called groups or families. And the reason they're called families is because those elements that are in these groups or in these families will have very similar characteristics. If you remember from yesterday, those elements that we saw reacting with the water were lithium, sodium, and potassium. So they all behave similarly. However, if you also remember that as you go down on the periodic table, they become even more reactive. So the potassium was more reactive than the sodium, and the sodium was more reactive than the lithium. So families have very similar characteristics, and that's why they're called families or groups. I want to kind of show you, if you pay attention here, notice that in this section, it says 57 through 70 and 89 through 102, rather than have each individual one in its place. But if you notice, those are down here. So 57 through 70 and 89 through 102 are put below the periodic table, and then placeholders are put here where they would be in the periodic table. The reason is actually pretty simple. And I can show you a little animation that I did here. Oops, that's not it. I'm going to start this animation, and you will see what happens if we take those bottom rows, 57 through 70 and 89 through 102, and put them where they are supposed to be. So if we take apart the periodic table, slide it to the sides, and then put 57 through 71 and 89 through 102 back where they're supposed to be, you see that, first of all, the periodic table looks a little bit more organized. However, it's pretty wide. So if you were going to make this a chart to put on the wall or try to put it into a textbook, it would take up a lot of space. So the whole reason that those are taken out and placed at the bottom of the periodic table, and then the two sides kind of squished together and put the placeholders, is basically just to save space so that it can fit on a wall or in your book. So that's just a little something to know. It's there's no other reason that these are placed down here at the bottom instead of where they're supposed to go, other than just for space. Those are often referred to as the lanthanide series, the actinide series, just based on the names that begin the series. So the names from the elements for the series. Okay, so that covers it for today. Go back and look pages 86 and 87 in your textbook. And tomorrow we'll do some practice with you coming up with the numbers of protons, neutrons, and electrons for some of these elements. Have a great day.